Hi, my name is Tom Paff and I'm president of Campbell Fittings. As you're well aware, the use of ferrules and sleeves as an attachment method for industrial hose is becoming very popular, in great part to the success of our Crimpnology program. Crimpnology is a term that we came up with to simply describe all of the technology involved in crimping, the design of the fittings, the ferrules, the sleeves, and the processes to put it all together. This short video is going to show you how very simple those processes are, and that by using those processes, you can build a repeatable, measurable, performance-oriented hose system as opposed to a hose assembly. Let me introduce you to some of the people that are going to help us with this video. Jeff Craig is Campbell's Vice President of Sales and Marketing, and he's going to describe some of the features of hose systems. Our hose systems specialist, Titus Jumper, is going to walk you through the actual process of crimping by crimping several assemblies. And Dave Riley is going to show you some special situations you may run into while crimping. Dave is in inside sales, and we like to call him the crimp doctor because he's available to you 8 hours a day, 5 days a week with any of your crimp questions. Let's get started with Jeff.
There are three basic elements to a hose system: ferrules and sleeves, fittings, and the hose. Let's start with the ferrules and sleeves. The sleeve is basically just a piece of tube. It's cut to length and sized. Ferrule is just really a sleeve with an attitude. It's got a turn-in at the end and slots. Now that turn-in allows the ferrule to grab a hold of the interlocking collar on the fitting and make a mechanical interlock. The cutouts here just really allow the metal to flow as the crimper comes down on it. The important thing is that whether it's a sleeve or a ferrule, it has to be compatible with the shank on the fitting. In Crimpnology, there are a lot of different sizes of ferrules and sleeves, but only two basic lengths. We have a standard ferrule and a long, a standard sleeve, and a short. The length of the sleeve or ferrule should match the shank length of the fitting. Now let me discuss the second element, the fittings. As mentioned, length's important. Why? Compatibility. Your shank should always match the length of your sleeve or ferrule. These are our cam and grooves. You can see we use a standard sleeve or ferrule in all of them. And this is a cam joint coupling. It also matches the same shank length as the cam and groove. When we get down here, we've got a ground joint coupling crimped to a 1,000-pound air hose. Higher pressures, higher temperatures, hence a longer shank, a longer ferrule. The other end of the fitting food chain, we've got a suction hose coupling, low pressures, low temperatures. We use a short shank and a short sleeve. Now this is a whole different animal. It's a crimp steam hose coupling. Because of the high temperatures and high pressures, plus the thermocycling that they operate under, we designed each of these around a very specific manufacturer's steam hose. And here we have the light duty ferrules that are designed around utility hose such as water, air, and nitrogen. Now one thing you'll notice as you look at these, in each case, the shank of the fitting stands just a little bit proud of the ferrule or sleeve. We do that on purpose. When you crimp, the material in the ferrule or sleeve will stretch slightly, and we allow for that so it grows to be the exact length of the shank. One more thing. Let me illustrate what happens when you use an incorrect length of ferrule or sleeve on a fitting. What I'm going to do is take the long ferrule, put it on a shorter shank, short ferrule on a longer shank. Now in neither case is the hose correctly supported. In this scenario, as the hose moves, because the stem's not supported, it's going to wear on the tube, and that can result in premature tube wear and even a failure. In this scenario, exactly the opposite. Now the cover's not correctly supported, so as the hose flexes, it allows the ferrule or sleeve to cut into the cover. That can result in premature wear of the cover, or again, a failure. It's critical that the ferrule or sleeve and the shank are compatible. Just as length of ferrule and sleeve is critical, so is shank design. This is a classic two-bump shank, designed to be used with band clamps. The two bumps locate a clamp in the center, the clamp at the end of the shank. Good for clamping, but less than ideal for crimping. Why? When you crimp a ferrule or sleeve down on this shank design, most of your pressure is exerted on only two areas. It's a 3-inch shank, but there's only 1 inch of raised portion, and that's where the pressure is exerted. It can cause 3 problems. The first could potentially damage the tube. The second is sealing issues, and the third is hose retention. The ideal shank for crimping has multiple serrations, all the same height. This allows the ferrule or sleeve to exert its pressure evenly over the entire shank, which is ideal for both retention, sealing, and also doesn't prematurely wear the tube.
Jeff described the first 2 elements of Crimpnology, the design and manufacture of our fittings, ferrules, and sleeves, all of which we can control. I'm going to describe the third element, the hose. The hose is the only element we cannot control. As you know, industrial hose has many shapes, sizes, which create issues when it comes to crimping. Given this, how do you establish a safe and accurate crimp specification each and every time you build a hose system? You use the Campbell Crimp chart. Now there's 3 sections to the Campbell Crimp chart: the table of contents, a procedure section, and finally the spec charts themselves. Now the procedure section, you're going to find a lot of important information about crimping, but I'm going to boil it down into 2 simple steps. Measure the hose and use the chart. Again, it's that simple. Measure the hose and use the chart. Now I'm going to get into a little more detail about those 2 steps. You can measure the OD with a pie tape, or you can measure the hose wall with calipers. We suggest the hose wall method because it's more accurate, and we explain this later in our FAQ section. Industrial hose ODs can vary dramatically, so when measuring the wall, we suggest taking 2 or 3 simple measurements. In this case, our measurements came to 278, 282, and 286. Now in your head, come up with a rough average. In this case, it's easy. It's 282. Now let's go to the chart. Here you're going to see an example of a page in our crimp chart. The highlighted section shows the couplings by name. This next section shows those same couplings by part number. In this column, you're going to see many of the different ferrules that are suggested. Now we took our hose wall measurements and came up with 0.282. Now scrolling down on this column, we're going to see that that number comes in between 2 different numbers, and that's okay. We're going to use 281, the closest number. And here you'll see that we connected the column with the row to get our suggested ferrule. Just to the left, you're going to see our crimp diameter. So by taking the hose wall measurement and using this chart, we've identified both the ferrule and the crimp diameter. So now let's crimp some hose. First, we're going to start with 2-inch chemical hose using a 2-inch Campbell Crimpnology nipple. I went to the table of contents in our crimp chart. It directed me to page number 10. First and foremost, and most importantly, we're going to take a couple quick measurements of the hose wall, avoiding any wires that may stick out or cuts in the wire, and I'm going to get a quick average of that. I'm going to go to my crimp chart. We're going to go to the hose wall column and finger down to the hose wall measurement we just got. At the top, you'll see the fitting that we're going to be using, and we're going to scroll down to the recommended ferrule to be used. You'll see just to the left is the crimp specification that we're going to use. Now we're going to assemble the hose. First by putting the ferrule onto the end of the hose and inserting the fitting into the hose up into the last serration, and then allow the interlock to come onto the fitting itself. Now we're ready to crimp. We're here at the Uniflex 380i. I've programmed the machine to our crimp spec that we've gotten. It has automatically told us to use a 62 die, which we've installed. I'm going to feed the machine, laying the ferrule on the bottom die. Using the mirror, I'm going to line up the back of those dies to come down on that ferrule for the interlock. Okay, the last part, or last step in our process is to take a measurement. We're good. And what you have here is a repeatable, measurable, performance-oriented chemical hose system. Now we're on the 3-inch petroleum drop hose using a Campbell 3-inch Cobra cam and groove. First, I'm going to start by measuring the hose wall. In this case, getting over the largest parts of the helical wires. Now I'm going to go to the crimp chart. Find my hose wall and the appropriate fitting and follow these across to the sleeve recommended. Just to the left, we find the crimp specification we're going to be using. Now we're ready to assemble the hose. Now that we have the hose assembled, I'm going to take the sleeve, slide it down till it butts to the end of the cam and groove. Notice we did not use a slinky in this, but now we're ready to crimp. I've entered the crimp specs into the machine, and now I'm just finishing up inserting the dies. I'm going to feed the machine, holding the handles. I'm going to line up the sleeve to the end of the dies. I'm going to jog it down slightly and then crimp it fully. And there you have it, a simple process and a perfect crimp. Now we're on the 2-inch lay flat. We're going to be using aluminum pin lug coupling with this. Now lay flat's a little bit different because of the thinness of the hose itself. So we're going to ask for 2 different measurements on this. We're going to ask for the measurement of the hose wall and the measurement of the fitting itself over the serrations, the OD of the fitting. I'm going to first start by taking the measurement of the hose wall and now the measurement of the fitting. Now that we have those measurements, I'm going to turn to the crimp chart, find my average fitting diameter over the bumps of the fitting, and my hose wall measurement, and follow that down to my crimp specification. I'm going to take that over to the appropriate sleeve to be used. Now we're ready to assemble the hose. First, I would start by folding the hose over, putting the sleeve on, and inserting the fitting. Take the hose up to the end of the fitting, but allowing just enough area for the pin lug to turn. Now we're ready to crimp. All right, we're all ready. The machine's set up, the dies are in place. With this one, we're using a backstop to the machine, so let's see how it works. And there you have it, a leak-free, lay-flat hose system.
Hi, I'm going to talk to you today a little bit about some issues that you may encounter while you're crimping. For a more realistic scenario, let's think of it as Friday afternoon. One of your best customers calls up and requires that he has an assembly manufactured and shipped before the end of the business day. You get your crimp chart out and figure out what you need, but you find that you're missing the ferrule you require. All right, the only ferrule that's available is 2 sizes too large. Do you think this assembly can be manufactured? Absolutely. I'll show you how it's done. Let's go to the crimper. I've had the dies installed in this machine as well as the crimp data. I'm going to put the part into the machine, line it up. All right, what we want to do is ask the machine to crimp. And we just want to crimp until we see some of the steel start to migrate between the die segments. And then we want to rotate the assembly, putting the ridge lines or the high points of the ferrule in the middle of the die segment and ask it to crimp again. All right. And we're good. Another measurable, repeatable hose system. I'd like to review one more situation you might encounter. And this time we'll go back to that same Friday scenario. All right, you have all the correct parts, but you don't have the right dies. Do you think you can make the assembly? Absolutely. Let's go over the crimper, I'll show you. I've set up the crimper with a die that is 3 sizes smaller than optimum, and I've closed it to the recommended crimp diameter. As you can see here, there are gaps between each die segment. If we were using the correct dies, there would be no gaps in this area. All right, let's do some crimping. I placed the hose into the machine, and I asked the machine to crimp until it meets some resistance. And then I'm going to open the dies up. I'm going to spin it. And then ask to crimp again. All right, I'm going to open the dies up, move it again, just to give it the high points that you may or may not see here on the collar. I'm putting it the center of the die plate or the die segment to actually move the ferrule around the outside of the hose. Perfect. Another measurable, repeatable hose system.
Jeff and I have done rather extensive traveling around the country, visiting with our distributors, discussing and demonstrating Crimpnology. And in those travels, we've come up with 5 or 6 of what we would call the most frequently asked questions. By far, and number one, the most frequently asked question is, can I use Campbell ferrules or sleeves on another brand of coupling, or vice versa? Is that possible, and can that be done?
Well, obviously, as Campbell's sales manager, I'd prefer that our customers didn't use other people's product.
Right.
But we recognize that there are going to be times, whether it's because of a spec or an emergency, you're going to have to do that. So the answer is yes, you can. What you've got to bear in mind is that when you use our products, it's a system. When you use other people's products, it's an assembly, and I'll explain why. This is actually a coupling and sleeve that one of our customers sent us. He had to get it out. He basically used our crimp spec with other people's components. Their sleeve is a bit thicker, and the shank of their fitting's a bit thicker, and neither of those variables was taken into consideration. So what happened, it actually caused him to over crimp this, and it actually crushed the shank.
So he's using a crimp chart that's designed to our coupling and our ferrule
Exactly.
on somebody else's, and those differences made the difference in terms of crushing it.
He went back to an assembly as opposed to a system. This is an example of a system. It's a 4-inch bull air hose. It's actually a 400 PSI hose that we blew in a test at about 2100, almost 2200 PSI. But again, it's our shank, we know the dimension. It's our ferrule, we know the dimension, crimped to our spec. Consequently, it's measurable and repeatable. And what that means is not only is this system measurable and repeatable, the pressure rating is repeatable under test.
So if somebody wanted to use our ferrules and sleeves, someone else's coupling, they could call us and we could walk them through the process to crimp that properly, but you would not get the system. You'd have a good assembly, but you wouldn't have the system.
Absolutely. Dave Riley has what we call Crimp Chart B,
Okay.
and he can help you through that situation, get you with a system out, or rather an assembly out the door.
Very good. Certainly up at the top of the list of questions is, why use the hose wall measurement as opposed to an OD? I got a fittings or a hose catalog sitting here. It's listing an OD. Why can't I just use that OD and go to my crimp chart?
There's 2 primary reasons. The first and most obvious is there's some hoses out there that are just really hard to put a pie tape around, lay flat being one. Another would be any kind of a hose that has a wire helix. It's basically got hills and valleys. When you try and run your pie tape around it, you tend to go over the hills and into the valleys, so you get an inaccurate reading. With both these hoses, gone with the dial caliper gives you a very easy reading of the hose wall. Another reason is when you determine a hose wall using the OD, you're assuming the ID is correct. And there are a couple different reasons why that may not be the case. Just the vagaries of hose manufacturing mean just as the OD can vary, so can the ID. Also, there's a lot of import hose now, and I suspect that that's metric IDs, and we're simply assuming or taking it to the closest imperial measurement.
Okay, good. Why use, or when should I use a sleeve versus a ferrule? Is there a rule of thumb? Is there a technical reference I can go to? How should I determine that?
Both. There's a rule of thumb and there's a technical reference. Let's start with the rule of thumb. If you're at all worried about what's going through that hose, and by that I mean the media, the temperature, the pressure, any of those stamp variables that you use when you put the components together, I'd say go with a ferrule. That mechanical interlock you get is an insurance policy. The extra retention that it produces is going to simply take into account that the temperature might go up, the pressure might go up, the media may get thicker. Low pressure applications where temperature is not an issue, gravity is typically the pressure, I'd go with a sleeve.
Okay.
But remember, any sleeve application, you can use a ferrule. And the science is basically on page 30 of our catalog. If you look at that, we have pressure ratings by hose type, by fitting type, and by ferrule or sleeve. And we also have a temperature derating chart on page 30, and that's a critical part, as you know, with stamp. It has to be factored in.
That's a good point. I'm a buyer. I have a situation. I've got an order that I need to get out. I don't have the hose on the floor. I've got that on order. I need to order the ferrules. I don't have the hose to measure. I've got the OD sitting there in my catalog. Can I use that OD in this situation?
It's a good question, but if you're the buyer, God help the salesman. It's the one time you have to go to the hose manufacturer's catalog. He'll give you a nominal OD. Go with that, and it'll get you close. If the hose runs undersize, you're fine. You can crimp down to that spec. The problem is the hose may run oversize, and if you're right on the limit of that ferrule or sleeve, then you may have a problem. So what we recommend when a hose is new to you and when you don't understand its characteristics, also order the ferrule or sleeve that's the next size bigger, and that'll compensate for it running oversize. To that end, if you end up with extra inventory, we'll take it back. No restocking charge. We understand that as you crimp, you've got to learn the hose's characteristics.
And based on experience, the people that we have that are crimping consistently really don't have an issue with that. Once they're out there doing it, you start to see tendencies in the hoses that you buy.
Absolutely.
And there may be an oversized tendency or an undersized tendency.
Right.
Dave Riley covered a couple of key points. One of his issues was talking about dies. If a customer of ours is looking at purchasing a crimper, or maybe they have it on the floor, what issues or what help can you give them on dies? Is there a die package that they can go to Uniflex or Custom Crimp or Fin Power? How does that work?
Absolutely. And I should say at this point that what Dave demonstrated is not what we recommend. We think you should have the closest die to the crimp spec you can. What Dave was showing is simply how to get out of a tight situation. Each crimper is a little different, and depending on how the dies come together, how the head operates, some are more die specific than others. Uniflex is very forgiving, Fin Power a little less so, but they're all a little different. And Dave Riley can provide the customer with a recommended die package for industrial hose. So when they get their new crimper, if they're looking at 2-inch, 3-inch, they can figure out what hose they're using, call Dave, and he can tell them with that particular manufacturer's what dies they should be getting.
All right, great. Well, thank you. I think that covers most of the key questions that we get. Obviously, if you've got any other detailed questions, don't hesitate to call our office. If I were to ask you what 2 points you took away from this video, you might answer measurable and repeatable. What I'd really like you to answer, though, is measure and use the crimp chart. This is an incredibly valuable tool. It's very unique. I hope this video has been a valuable tool, and I hope you use it often. If you ever have any questions about crimping whatsoever at any time during the week, don't hesitate to call the Crimp Doctor at our home office. Thank you very much.